Welcome back everyone. So in the last video we solved to be or not to be, and in this video we are going to solve counter 2, which is an advanced version of question number 2, that is counter. Okay, so what we have to do is we have to write a function, create counter. This function, it should accept an initial integer. In it should return an object with three functions. Now these are the three functions. The first function is increment, which should increase the current value by 1 and then returns it. Decrement reduces the current value by 1 and returns it. Resets sets the current value to init and then returns it. Okay, now let's see the examples. So in the first example, init is 5 and we called increment, reset, increment. So when we call the increment, it increment the value and returns. So 5 is incremented to 6 and then return. Then we reset it. So on resetting, what we'll do is we reset the value to the initial value, that is 5, and return it. So that's 5, and then in the next call decrement, we'll decrement the value and then return it. So 5 is decremented to 1 and that is 4. In the example 2, init is 0 and the calls are increment, that is increment and return, that is 1, increment 2, decrement 1, reset, initial value is 0, and then reset again, same value 0. So we have to complete this. So what we'll do is we have to return an object, and this object will be having three properties, that is increment, then decrement, and the last is reset. Okay, so what this will do is this will increment and return. So first we'll have to clone these init values because we'll need that value to reset the value. So for example, we can say constant init value, that is init. Okay, so we'll use this init value here. So first we'll increment and then return, and in the decrement we'll decrement and return, and in the reset what we'll do is we'll set the value of init value equals to init and then return it. Okay, so first we'll see whether this works or not, and then we'll understand it properly. So let's see. Okay, so it says plus plus. Okay, we have used constants, we'll be using let here. Okay, so both the test case has been passed. Now we will try to submit this. Okay, so our solution got accepted, and now let's understand it. So this is a problem related to closures. So what we are doing is we are creating this function. So let me properly arrange this. This is a function. So whenever someone calls this function, we will return another object. So we are returning this object. Now this object has these three arrow functions. These arrow functions encloses two values. The first value is init and the second value is init value. Okay, so these are initially both the same. So let me show you on the whiteboard. Okay, so initially when someone call create counter, so let's say create counter with a value of 10. Then again someone call create counter with a value of, let's say, 15. So these two call will return this object. Okay, so this object will have increment, decrement, and reset value. Similarly here, increment, decrement, reset value. So this is an object. Okay, now this object has arrow functions. So these functions has enclosed two values. The first value is init, which is this value, and the second value is init value. Okay, which is nothing but the equal to init value. Now this is closure. So whenever we call or someone calls this function, this object has enclosed two values, init and init value. Now when someone calls increment, what we'll do is we'll increment this value and return. When someone calls decrement, we'll decrease the value of init value and return. When someone calls reset, what we'll do is we will set the value of init value equal to init. Since this object has enclosed these two values, we are not changing this value. What we are doing is we are changing the clone of init value, that is init value. And when someone calls the reset value, we set the init value with init. So what I'm trying to say is that whenever someone calls create counter, a different instance of this created. So each instance has their own value for init and init value. Okay, so you might know about the stack space. So whenever someone calls a function, an entry is created on the stack spaces. So for example, someone calls the create counter. So a stack entry is created, and in that entry, these variables are stored. If you call the same function again, another entry is created. So for example, if there is a value or variable init in this stack entry, and if there is a variable in this stack entry, these two are not same. These two lies in the different entries. Okay, so these two variables are different in different stack entries. And whenever someone calls increment, decrement, or reset, their respective variables are changed. Okay, so that's it. We'll try to run this code against for these test cases, and the solution is accepted. Okay.